Good morning student. Today our topic is filter circuit. Previous class we have discussed about what is the rectifier, half wave rectifier, full wave rectifier and discuss over it. Today we have discussed about why filter is needed. Filter is used to pass something which is desired and block the remaining. A filter circuit removes the AC component of the rectifier output and allows the DC component to pass to the load. Again, the filter circuit is also used to pass the signal of certain desired frequency and block the others. So obviously a filter should be placed between the rectifier and the load. So if we see that if we take the certain rectifier out input voltage and suppose this is the filter circuit, here we take the supply from the rectifier at the output we take to the load, from the load we take the output. Suppose this is the VL output voltage. Depending upon the reacting components, filter can be classified capacitor filter, inductor capacitor filter and pipe filter. So first of all we discuss about inductor filter. So what we see inductor filter, there we use a inductor, it is denoted by L. Here is the RL, from the RL we take the output VL. This is the rectifier, supply from rectifier. So what we see, the function of inductor filter may be viewed in terms of impedance. The choke offers a high impedance to the AC components and but offers almost zero resistance to the desired DC components. Thus ripples are removed a large extent. And if we see the DC of the RC series with means DC frequency is 0, the RC is series with the RL in form voltage divider, the DC voltage across the load VL is given by VDC into RL by RC plus RL. So that means VDC by 1 plus RC by RL we can write. So VDC is the voltage of the output from a rectifier. Usually RC is mass molar through the RL. Therefore the whole DC voltage is available across the load, means RL. So Fourier series of the rectifier output, we given that Fourier series is VL equal to VL maximum twice pi minus 4 by 3 pi cos 2 omega t minus 4 by 15 pi cos 4 omega t minus dot dot dot. Since the reacting components increases with the frequency, better filtering of the higher harmonic components takes place. So effect of third and fourth harmonic can be neglected for the simplification. So if we see that, then we get VAC max, neglecting the higher components, we get 4 by 3 pi VL max into RL by L square plus XL square, neglecting the higher components. So RMS value of the value is given by VAC RMS equal to 4 by 3 pi root 2 into VL max into RL by root over RL square plus XL square. So RMS value of the AC voltage drop RL is given by VAC RMS. And uh, ripple factor. Ripple factor means AC components VAC RMS by VC. So ripple factor we get VC RMS by VDC is nothing but 4 by 3 pi root 2 into VL max into RL by RL square plus XL square by 2 by pi VL max. So we get, after calculating, the root 2 RL by 3 root over RL square plus XL square equal to root 2 by 3 1 plus XL square by RL square. Since we know that XL equal to twice omega L, so the equation is simplified. Root 2 by 3 1 plus 4 omega square L square by RL square. Then if we take the calculation, then we see that if 2 omega L is very greater than RL, then rectification frequency, we get ripple factor is given 2 RL root 2 RL by 3 into 2 RL, means RL by 3 root 2 omega L. This is the equation we get. Then second is capacitor filter. Capacitor filter, same here, there is a capacitor in replace of inductor. Here RL, take the output from VL, here the supply from rectifier. In capacitor filter, if we take the input waveform is like that one, means this is Vx max and this is Vx minus Vx max. So if we see the waveform, whatever, if we see for inductor waveform, the inductor circuit, the waveform should be, this is the without filter, the circuit is like 0, pi, 2 pi, 3 pi, and the waveform is like this is the VL, this is VL max. For capacitor means first it is charging half wave rectifier, then it is discharging this type of waveform. Means if we take here, then for half wave 0 to pi, then here 2 pi, 3 pi, we get that type of waveform. Means if we know that half wave rectifier, there will be first there will be forward bias, so we get some value, and the reverse bias we no get any value, then again forward bias we get the value. So first this is charging, then discharging, we get this type of waveform. If we take the full wave rectifier, using capacitor, then the filter circuit will be like that. This 0, pi, this is half wave, this is for full wave. 2 pi 3 pi. So the similarly then charging, discharging, charging, discharging, charging, discharging, this type of waveform we get. So for full wave we get this type of waveform. If we take the what is the calculation, then if we take the calculation part, then for the approximate value, the total change of voltage equal to VR and ripple output voltage, total output voltage VR, and the average of DC value output voltage VDC is the voltage between the VL max and maximum value is B and C. So VDC is given by VL max minus VR by 2. So the total charge loss during the nose charge at T2 is Q discharge. Discharging time is IDC into T2. The charge is replaced T1 time T1 in which voltage across the VR volt. So charge divided by Q charge is given by C into VR. Instead it Q charge is equal to Q discharge in steady state. Charging is equal to discharge. So CVR is equal to IDC into T2. So VR equal to IDC T2 by C. Assuming T1 very less than T2, T1. So T2 equal to T equal to 1 by F. So VR we can write IDC by FC. So from here VDC equal to VL max minus IDC by twice FC. Twice FC. Then from the resolving ripple factor we know that ripple factor we know VAC AC max by VDC, and VAC max equal to VR by 2 root 3, and VDC here we get 2 root 3 IDC into RL. So here we get IDC by 2 root 3 IDC RL FC, or we can simplify 1 by 2 FCRL. This is the simplified equation. If we take full wave rectifier, full wave, then T2 equal to T by 2 equal to half, because both the diode are conduction. So ripple factor V, so we write T that equation, then PR we get IDC by twice FC, and next VDC, what we get VDC equal to VL max minus VR by 2. So VL max minus IDC by 4 FC. VAC RMS equal to VR by 2 root 3. So ripple factor equal to VAC max by VDC means VR by 2 root 3 IDC into RL, or 1 by 4 root 3 FCRL. This is the equation. In case if we take that RC filter, LC filter, sorry, LC filter, next point. LC filter means here inductor and capacitor both are present. Here we take the output VL supply from rectifier. Same L and C condition, the regulation, and if we offer L and capacitor we know that high capacitance value, so regulation VL is given by twice by pi VL max by 4 by 3 pi VL max cos 2 omega t, considering the neglecting part, higher part, so VDC equal to twice by pi VL max, neglecting higher terms. So considering the so we get VDC equal to that one, and if RC is the choke resistance, so VDC equal to twice by pi VL max minus IDC into RC. If we take that XL, we know that twice pi RL and the reactance in the second harmonic, so AC of the IAC RMS we get 4 by VL max by 3 pi root 2 XL, so we get twice by 3 VDC by XL. So as VDC we know that VDC equal to twice by pi VL max. So AC voltage across the load is given by VAC RMS is equal to IAC RMS into XC. So if we get this is twice by 3 VDC into XC by XL, where XC equal to twice 1 by twice omega C. So capacitor in second harmonic frequency. So ripple factor we get VAC RMS by VDC, so twice by root 3 XC by XL. If we calculate, we get the value is twice by 3 into 1 by 2 omega C into 1 by 2 omega L. So what we get, the value is 1 by 6 root 2 L omega square LC. Then last we take about L filter, pipe filter. Pipe filter means the pipe filter is a filter consisting of C1 followed by L section and L followed by the C. Means is pipe means it's Roman Greek letter pi, it's symbolically so, and looks like a pi Greek alphabet. Means the picture is here that there is a capacitor, there is L inductor, there is a capacitor, another capacitor, this is C1, this is C2, here the RL, here we take the VL. So it's look like a pi, there is L, there is capacitor. If we remove the two terms, it's look like a pi. So if we know that how we calculate for that case, if we see that what happens here, for the C1 capacitor is offered that is proportional to frequency, so it's offer low reactance to the AC components of the rectifier but infinite resistance to the DC component. So C1 pi pass the appreciable amount of AC to the ground, DC component go to the L. And for the second case, inductor, the reactance of inductors is proportional to the with the frequency. So it's over high resistance to the AC but zero resistance to DC. So L allows the DC components to pass through it without the AC components. And for the C2 is remaining AC components to the ground and DC components allowed to the it. So if we take the what is the ripple factor calculation? Vr is given by the equation IDC by twice fc1, and RMS value VAC RMS equal to Vr by pi root 2, means 1 by pi root 2 into IDC by twice fc1. So the value is twice by IDC into xc1. xc1 is equal to 1 by 2 omega c1, means 1 by 4 pi f c1, because omega equals to twice pi f. So VCRMS L across the obtained by multiplying xc2 into xl. So VAC equal to VAC into xc2 by xl. So what we get, root 2 IDC into xc1 into xc2 by xl. Now ripple factor, what we get, VAC dex RMS by VDC, means twice pi IDC xc1 xc2 they by divided by VDC into XL. So what is the equation? Twice IDC xc1 xc2 by IDC RL XL. So this is equal to twice SC1 SC2 by RL XL, or we get twice by RL into 1 by 2 omega C1 1 by 2 omega L. So we get the equation equal to twice pi omega 8 omega cube C1 C2 L R L. So this is the for pi filter. These are the today's lecturer. We get the there are 4 types of filter. Generally we use L filter, LC filter, capacitor filter, and pi filter. How the waveform we see that how we get the filter, we get the proper output.